Another day, another project. So today we're continuing to prep for Alaska. And while we're in Alaska, we're going to be doing a lot of boondocking. Now, we've done some boondocking in the past. When we were at the Albuquerque Hot Air Balloon Festival, we did it for a little over a week. And things worked out pretty good. We would run our generator in the morning for about an hour to 2 hours to bring the batteries up. And then the panels that we had would keep them up throughout the day. But we ran our fridge on propane, our water heater on propane. So if we're gonna go for 3 months in Alaska boondocking, we would like to use electricity as much as possible. So what I'm doing today is, you can see this panel down here. That's a 300 watt panel. And there's another one right here. So I'm gonna add about 600 watts to our current setup, which is about 480 watts of panels. So that should bring us to a total of 1,080 watts of electricity. And the goal is that we shouldn't have to run the fridge on propane, and we shouldn't have to bring out the generator each day. So that'll be nice. But yeah, right now I'm just working on the wiring for it. I had to move one of my panels to make room for the 2 new panels. These 2 new panels are going to be tiltable, so we'll be able to tilt them towards the sun to pick up a little bit more power. But yeah, the other thing that I'm doing when I'm adding these panels is changing out my system a little bit. I'm putting in a different charge controller. I'm going from a PWM charge controller to an MPPT, which is going to be more efficient as well. When you go from a PWM to an MPPT, you say you pick up about 20%, if not more, in extra power. So it's like adding a couple of more panels on your roof, really. So I'll show you that system here in a bit. Also switched out the inverter converter. We've gone with Victron products this time instead of the Magnum. And the reason for that is the Victron is less expensive. Not in quality, but in price. They're a European company and they're trying to gain market in the United States, so they're just getting going. But I feel that their product is actually superior to the Magnum hybrid that you see in so many rigs. And we'll talk about that more when I show you that Victron product. So that's the plan for the day. We'll see how it goes. Let's go down and check out the front, look at the MPPTs and Victron. So here we are in the front of the fifth wheel, in that front storage bay. This is where the battery system is kept. So you can see right here, in these 2 boxes, which are sealed off and then vented out because we're using lead acid batteries. We've got 6 golf cart batteries in there, which gives us approximately 660 amp hours. You can see up here in the back, these 2 right here, those are our charge controllers. They're MPPT, Victron charge controllers. They take the energy from the solar panels and connect it to the battery and charge them up depending on what state the batteries are in. And once the batteries get towards full capacity, the charge controllers slow down in their charge cycle. And they'll just do a trickle charge at that point. You can see up top here, these are my wires coming in from the solar panel. These first black wires are the strings coming in from my 480 watts of panels up there. And these wires right here are the wires coming in from the new 2 300 watt panels. One thing that I've done is I've switched my panels from being hooked up in parallel to series now. So what that does for you is when you hook them up in parallel, your voltage stays the same, but your amperage increases. So you need a thicker wire to run that amperage down to the front, to the batteries. And when you hook it up in series instead of parallel, you can use a smaller gauge wire because there's less amps running through it. So series increases the voltage of the power, but it keeps the amperage low. And the way electricity works is the more amperage you have, the thicker the wire needs to be, but voltage not necessarily. So you can run more power through smaller wires if you increase the voltage. But when you do that, you have to use an MPPT controller like we've got up here. You have to use an MPPT rather than a PWM, because a PWM controller can only capture like around 14 volts worth of power coming through. Any voltage higher than that gets lost. So most of these panels output more than that, especially when you hook them up in series. Like these panels hooked up in series are probably going to produce 50 to 60 volts worth of power. So most of that would get lost in a PWM. So switching to an MPPT gives you better efficiency, and you can hook things up in series rather than parallel, keeping your wires small. Last thing I was going to show you in here is, I'm not sure if you can see this. There we go. So we've swapped out the Magnum Hybrid to a Victron Energy Multiplus. Still at 12 volt, 3000 watts. Or, yeah. This will do 3,000 watts, and it's 120 amp, which is very similar to the Magnum that we had in there. The big difference is this: the Magnum was around $500 to $600 more than the Victron was, and as far as quality goes, I can't tell a difference in the quality. One thing that I do like about the Victron that's better than that Magnum is the Victron does power assist, just like the Magnum does, but the Magnum had preset settings for, I think, 50 amps, 30 amps, 20 amps, 15 amps, and then maybe 10 amps, just preset settings, whereas the Victron also does the power assist, but it does it in 0.5 amp segments. So you could say that. So where this comes in handy is when you're using a generator, because generators, they're all over the board. You can get a 1,000 watt generator, 1,500 watt generator, 2,000 watt generator. There's lots of different types of generators out there. So with the Magnum, you could just set the power assist to something close to what your generator was. Whereas with the Victron, you can set it exactly to what your generator is, and then never go above what the generator is putting out, because what the Victron does, like the Magnum, is this thing, when you're boondocking, and let's say you're plugged into your generator, and you take more power than what your generator will allow. Like say the startup of your air conditioner, or you're starting up a hairdryer and the microwave. The power assist pulls the extra power from the batteries for that brief amount of time. And then as soon as it's done, it kicks the extra power back into charging your batteries back up. So obviously you don't use that when you're completely boondocking with no generator. You're just pulling everything from the battery. But let's say you're a 50 amp rig and you pull into a RV site that's only 30 amps. You plug into the 30 amps and you don't worry about it, because the power assist grabs the extra power from your batteries so that you're not blowing that fuse on the 30 amp receptacle. So that's a great thing about these power assist modules like the Victron and the Magnum, which is very common nowadays. But we've switched over to the Victron because in actually switching over, it paid for my new panels that we put up there. And you can fine tune this Victron better than you could the Magnum. So, oh, I want to show you one other thing here. This we never had before. You see this right here. I've put in some bus bars to help clean up the installation. So that's the positive bus bar. And over there we've got the negative bus bar. And what the bus bar does is that it creates like a hub for all the electrical connections to go through, rather than trying to run all of these individual wires into your battery and find different terminals for them. And then lastly, on this side, as you can see right here, we've put in a shunt. Now what that shunt does is that's used if you've got a dedicated battery monitor. So we've gone with a Victron battery monitor. And what happens is all of the power runs through that shunt, and it accurately reads every single amp that goes through it, so that it tells you on your battery monitor how much battery life you've got left, rather than it making a guess as to how much battery life you've got left based on the voltage of the battery. So the downside to the voltage is that it's not really accurate, because as you're drawing a load from your batteries, the voltage reads lower than what the actual battery capacity is. And when you're charging your batteries, the voltage reads higher than what the actual battery capacity is. So you don't get an accurate reading when you're trying to boondock, which is important to really know where your batteries are at. So we've added this shunt, and that connects to a battery monitor inside, which will then tell us exactly where we're at with our battery capacity. I think that's it. Let's go inside and I'll show you the monitor that's used with this Victron setup, and I'll show you where I put the battery monitor as well. Alright, back inside. I want to show you where all the wires come through. This is the display unit where you can control everything. It's called a Color Control GX. It's made by Victron, and I've got it mounted on an inside wall here inside our mid-level bunk. This wall that's right behind me, this is a hollow wall that goes all the way from the roof all the way down to a storage compartment underneath. So it makes it really handy for running wires all the way to your front compartment, where the battery and controllers, inverter, converter, where everything is stored. So this wall, you can see here, I went ahead and made a custom piece of wood to mount the monitors on. And over here, that's the actual battery monitor from Victron. Let's see if it zooms in there. There we go. So right now that's showing amp hours. No, right now that's showing battery percentage left based on how many amps have gone out of the battery. And then over here on this one, this is the Color Control GX. Everything plugs into that. So the battery monitor goes into there, the inverter converter goes into it, the two charge controllers, they all go into there, and it's constantly monitoring. As you can see on the top, the AC loads going out, PV charger, that's the MPPTs, how many watts is coming in from there. This is the battery monitor showing how much battery life we've got left. So pretty neat that everything is all in one place. Also on here, we can go to another screen. Let me show that. And it shows you all your details of your different components. So the B&B 700, that's the battery monitor, the Multiplus, that's our inverter converter, and the solar charge controllers, each showing how many watts that those are putting out as well. So pretty handy little system that Victron makes. It's did a little bit of reading about it, and it's actually a Linux computer that's inside there. So it's fully updatable. It controls all the firmware for everything that you've got plugged into it as well. So you don't have to individually update firmware as they come out. This thing will push it out to you. This will connect to Wi-Fi or to a hard Ethernet cord. So it's online, and there's actually a website that you can go to and register your device so that you can get all the information even if you're away from your rig. You can also do a remote console session so that you can control this screen from anywhere. So if you're out in town, you're wondering what your batteries are doing, you can check it through this system. So very cool. I've hooked up those last two panels, so let's go on the roof and take a look at what that looks like up there. Alright, we're back on the roof. I'm going to show you how this final install turned out. You can see down below here. Those are the two new panels. Each of those is 300 watts. Now back on this back corner over here in the RV, that's one of my old panels. I ended up moving it because it used to be in this location right here. So we still have the other two panels. Those, you see these two panels and that one in the back corner. Those are hooked up in series to each other. That brings about 480 watts. And then this panel and this one are hooked up in series to the other controller, and that gives you another 600 watts. The other thing I wanted to show you is the mounts that we used. Because the roof of our RV is curved, you have to use a little bit different mount. So you see this mount here that we're using, that mount has a curve to it, and that allows this thing to articulate. See, there's bolts here that you can loosen up, and so this plate here will articulate and move depending on your surface, because your panel is going to be flat and the mounting things for it is going to be flat, but usually you'll probably have you'll have a rounded roof. And especially when you're working with bigger panels like these 300 watt ones, they extend over a portion of your roof. So in this case we had to use those special mounts in order to get it mounted. Let me show you this one over here. It's even a better example. Let's look at that. I don't know if you can see that. Yeah. So you see how the panel is flat, the mount is curved, and then the actual part that you drill into the roof is flat. So that's how that works. Got all my wires running here. This is the old entry block going into that wall I showed you before. This is the new one. I haven't glued it down yet, but that's the last step. So I hope you enjoyed this video, learned a little bit about Victron products. I've been impressed with them. I like the configurability of them, the fact that they all work together. And switching to an MPPT controller is going to give us a little bit more output, especially, you know, now that we've got more panels. That's going to obviously give us more output, but the MPPT just makes it a little bit more efficient as well. Alright, a few last steps. We'll be starting our trek to Alaska. See you in the last frontier.